follows is that the third in my series of videos about how a computer works. The first one spoke about how registers work, the next one spoke about the bus, how data gets to and from registers. This one's going to focus on RAM or memory. In particular, how we can send an address to RAM, so how we can put, how when the address comes in to memory, how we can select a particular area, and then how we can either send data to that area or, on the data bus, basically retrieve data from that area. Okay, so we're going to focus very much on memory today. Alright, let me just clear the screen. And the one thing we need to make memory and RAM work is a thing called a decoder. Okay, and so the diagram's a little bit confusing, so I'm just going to break it down a little bit. And if you remember, the signal sort of breaks into two parts where there are these dots. So the B signal, once it's gone through this NOT gate, after that will go here, and it will also go here. It will not come down here. Okay, so just to make that a little bit clearer, I'm going to follow all the A signals across, or the A path, even through the NOT gate. I'm going to follow that with a red line. Alright, so it goes down there, it goes down there, oops, wibbles there a bit. I'm going to follow the B1 with a blue line. Alright, and I'm just going to, as you can see, that blue comes down there, down there. Alright, I'm going to leave that bit just to make it clear. Jumps over there if you like. We can put a little hiccup there. How's about that? And then this down here will come down there, will go along there, and then along there. So you can see the path that the blue and the red signals take. And it's just worth saying actually that this A and this B here, we've been talking a lot about bytes. These are bits, so either 0 or a 1. Basically an electrical current is high voltage or low voltage depending whether it's on or off. That's all that is. And similarly for B. And we've got basically, 4 combinations here. We can set A 2 ways, we can set B 2 ways, so in total we've got 4 combinations. And that's effectively what the decoder does. It allows us to pick one of 4 combinations if it's set up like this. So if I set A to 0, okay, and B to 0, and I just follow the path through, well, that's going to become on. If I follow this one through, once this one becomes on, I'll just say all the others, of course, are off. Okay, so that's off and that's off. So clearly, with this current configuration, with the A and B, both 0, well, we've already said those two are going to be off. And, well, it will turn A on. This one here will also be on. Okay, so this one's clearly on because when A goes through the NOT gate, it turns on. When B goes through the NOT gate, it turns on, so that will clearly be on. And finally, this here will be off because it doesn't get the signal. Remember, we jumped over the path here. This follows through to there. That will be off. Okay, it's not coming from NOT part, which turns it back on again, so that will be off. Okay, so when A and B are both 0, we get this selection, the first one selected. And I think it's pretty clear what's going to happen next. Let's say I turn A and B, and I'm going to have A off and B on. Alright, so we'll change this. It's now going to be on. Follow the signal through again. Well, that's still going to be on, so that will be on there. However, the signal that we had before is now 1 here, so a 0 here, going through this. Remember, this is an AND gate, so that's now going to be off. Okay. What about this here? Well, the 1, where's this coming through? This here is coming from there, so that's receiving an on signal from the B, so it doesn't go through the NOT gate. Okay. However, what does it receive from the other one? And that would also be on. Okay, because you can see the A is off, it's been turned on there, so it gets turned on there. So that's going to be an on for that one. And it's pretty clear because A is off that these two are going to be off. Alright, so you can see what this is effectively doing. It's allowing me to go through all the different combinations of A and B, the 4 combinations, and basically turn one of 4 combinations on. Okay, there's 4 combinations you can possibly get by combining a 0 and a 1 with an A and a B, and you can select one of them, effectively 1 to 4. Okay, So that's a basic decoder. They do get more complicated, and you can see here I've got a little truth table that's basically representing what I've done above. So A and B 0, then the first one's 0, the others are off. A 0, B 1, then that's clearly off, and so on and so forth. You can follow the rest through. It's not particularly hard to do. Okay, they can get a little bit more complicated. If you follow through to the next diagram, let me just clear the screen again. Pause. Alright, well, here we've got 3 signals, so no prizes to guessing that now we've got 2 times 2 times 2 equals 8 ways of signals we could possibly turn on or off. Okay, we can just select one of these effectively. Alright, so, and you know, I'm not going to go through the whole combinations thing again, but you can pretty clearly see if that's off, that's on, if that's off, that's on, if that's off, that's on. So you can very easily see that if I turn A, B and C all off, that first input will in fact be on. Alright, okay, alright, so that's a slightly more complicated decoder, and again they can get as big as you like really in this sort of format. It's really, I don't think it's difficult to see how to set this up. It just gets more and more complicated really. And of course, why is that 16? Because when 4 wires come in, because 2 to the 4 is 16, why is that 32, 2 to the 5 is 32, etc. Okay, so you can imagine this configuration can just build up as much as needs be. Alright, so next thing we're going to look at is making decoders with decoders. This will be the last thing we say about decoders. And actually it's sort of a little bit easier to understand it in this way. You know, if we want to make a 4 times 16 decoder, so 4 signals coming in, 16 possible options we want to select, only one of. Okay, remember that's always the point, we're always selecting only one. If I want to, basically this, depending on the 16 combinations here, one will be on, all the rest will be off. Alright, now if I set them all to 0, alright, so let's say everything here is 0, what's that going to turn on? Well, A and B will go into here. When they're both 0, this one will be on. Alright, all the others will be off, so they'll turn everything off they go to. C and D, when they come into here, probably should say C and D there rather than A and B, but you can imagine all that really is echoing the fact it's the same decoder. We'll turn this on, and consequently the first one will come on, all the others will be off. Alright, so, and you can go through, and again, it's not a particularly difficult exercise, just follow the wires around to work out what's going to turn on and what's going to turn off with this 4x16 decoder. Alright, so effectively that first one will be on when they're all 0, the second one will be on when we've got all zeros from the first 2, which is pretty clear. Okay, and we've got basically, so you can just follow the second one through, maybe we'll just do that. So the first one will be on 0, 0, 1, well that means that these two, this will be on. Alright, so all of these will be on. Alright, all of those will be on, and well, what's going to happen? Well, from here is going to be on 0, 1, okay, because those are the second 2 bits. And here we've got A would effectively be 0, 0, 0, 1, and what comes into here is that second 2 bits there. So what's going to be on here? Well, that'll be on, but it won't matter because that's off. And most importantly, that will be on. Da-da, and that bit's going to be on. Everything else will be off. Okay, so that's a more complicated decoder. So now we're going to build up to how we can use this to effectively to make RAM, if you like. Okay, so this is effectively 2 decoders here. We've got this over here. You can think of as, if you think back to our first diagram, that's the address bus, and it's setting a byte into this register here. And the top 4 bits of this byte are going into this 4x16 decoder, and the bottom 4 are going into this one. Okay. Now, effectively, that's going to allow us to, let's just put an example. Let's say the address bus has, and I'm going to work it so the top bit, the top one here is 0, all right, and then the second one down is this one, and similarly over here, the top one is the 0, 1, and that follows through from what we've done before. So let's say we've got a byte that's 0, 0, 1, 0, 0, 0, 0, 1. Okay, that's going to allow us to uniquely select a pair of wires. There won't be another pair. That, yeah. Okay. So what's going to happen in that case? Well, 0, 0, 0, 1. If I follow that down my list, that's going to be that wire. Okay. And if I follow the other one down my list, it's going to be the second one from the top. It would be that one. All right. So that will basically turn on one intersection, one unique pair of wires, if you like. Okay. Which allows me basically to turn underneath each of these intersections. Okay, there is a register. So if you think about that, how many registers have we got altogether? We've got, well, there's 16 across the top, 16 across here. So that's 2, 5, 6 registers. Okay, and this allows us to use a byte to uniquely select one of those registers, because there's only one byte underneath this pair of wires. All the other wires are off. Okay, if we send this byte through, all the other wires are off. Only this one is on. All right. So we can, if we now look in a little more detail at what's happening here, because if you think underneath each intersection, we've got this bus effectively coming to and from. Okay. And we'll just see that in more detail. So I'm now going to, if you like, zoom in on this particular intersection that we've selected, and we'll see what happens. There's going to be a register underneath that. Alright, so again, we'll just clear the screen. Okay, so this is an AND gate. So we've turned this on. So our signal here is going to be, that will be on, that will be on, and consequently what comes out of here will be on. So if you follow that through from there, it's going to turn that on, and it's going to turn that on. Okay, again, remember where the dots are shaded, you've got these little nodes. That means that the signal can split there. Okay, it can't split here. Alright, good. So both of these will be on. Alright, and all the others, every other intersection will have either this one off or that one off. Okay, because if you remember, we had one of the 16 across the top on and one of these down here off. So if we move one way or the other, we're bound to turn one of them off. Okay, so now the set comes in. Let's say we're going to set the register. All right. If I turn this on, well, then that path that will flow up there, that will come up there, that will go into there. All of a sudden, the set to this register will be on, and what's in the bus will go into that register. All right. And the bus is connected to all of the other registers that are underneath each intersection, but this is the only one that can be enabled with the set, because it also has to have the two wires that uniquely define it, uniquely identify it, turned on as well. Okay, as you've said many times. So alright, so that's what's going to happen if I want to set memory into RAM, and let's just see what happens if I want to actually send memory from RAM out again. Alright, well, this time, rather than, it's reasonably clear what's going to happen now. Okay, rather than have the set turned on, okay, let's just put back what's happening with the two wires that uniquely identify it, so they're both on. Let's say I now turn the enable on, so this one's now on. Well, it's just going to go into there. Alright, so this one will be on, the set will be off. Okay, you clearly, you know, there's intelligence behind selecting these, but you wouldn't want to enable and set at the same time, would you? That's reasonably clear. So if you're going to enable to allow something to come onto the bus, you turn the set off. Alright, so now rather than set being on, the enable's on, and out comes the data from the register and can go wherever it wants to on the bus. Okay, or wherever, you know, well, wherever the bus takes it, I guess. Okay, so that's basically how RAM works. Once again, well, just move on, and you know, just a very quick point to say, obviously these diagrams get simplified. One important point, actually, this is quite a common term, MAR. It stands for Memory Address Register, and all it means is you send the address to this register, and it gets broken down into two parts and identifies your point. But it's basically, it allows you, it's the address of the bit of data you want. And then, of course, this is the input-output bus, and depending on whether you've put set equal to 1, you've turned set on, or you've turned enable on. Okay, and again, the diagram can be made even smaller. And remember, that is a bus. That's just 1 byte. Okay, just the difference between the way the wires are notated. All right. So that's basically how registers work. So finally, just clear that, shift pause, and just to say, most of this information is coming pretty much straight, a few bits I'm adding here and there, but most of it. But how do we know? From J. Clark Scott. Okay, so I'm kind of learning how this works at the same time as explaining it to other people, I hope. Okay, so thanks for listening.